Hello everyone. In our last video, we learned how to write the equation of a line when 2 points are given. Now we're going to study two important relationships between lines. Those two ideas are referred to as parallel lines, perpendicular lines. So let's begin with parallel lines first. Parallel lines have the same slope. Parallel lines have the same slope as indicated by this drawing here. These two lines are parallel. Notice the slope is the same. They will never intersect. So parallel lines never intersect. And they not only never intersect, but they have the same slope. Because they rise or fall at exactly the same rate, they have the same slope. For example, if we have y equals 3x plus 2 and y equals 3x minus 5, these two linear equations have the same slope. That slope is m equals 3. So the slope for these two equations is the same. Therefore, the lines are parallel. Let's look at example 1. Example 1 says determine whether lines are parallel. So we have line A, which is y equals 4x plus 7. And we have line B, which is y equals 4x minus 9. The slope of line A is m sub 1 equals 4. Remember, the slope is the coefficient that is ascribed to x. The slope of line B, or m sub 2, is 4 as well. Since the slopes are equal, these two are parallel lines. Parallel lines. So we can write it as m sub 1 is equal to m sub 2. Therefore, they are parallel. Now let's look at perpendicular lines. Perpendicular lines are essentially negative reciprocal slopes. Perpendicular lines are negative reciprocal slopes. So for example, a perpendicular line intersects to form a 90-degree angle. So for example, if we have one vertical line like this and a line like this would be considered two lines that are perpendicular. Notice they cross and they form a 90-degree angle. Perpendicular lines intersect to form a 90-degree angle. Their slopes are negative reciprocals. For example, if one slope is 2, suppose if we have m sub 1 is equal to 2, well, m sub 2 would be equal to negative 1/2, because that is the negative reciprocal of m sub 1. If one slope is negative 3/4, then the perpendicular slope would be 4/3. A useful test is this: m sub 1 times m sub 2. And if the outcome is 1, those two slopes are perpendicular. Excuse me, negative 1. So if you multiply the slopes together, two slopes, to find out whether or not they're perpendicular, if you multiply the slopes and the outcome is negative 1, those two slopes are perpendicular. Let's look at an example. So we have example 2. Determine whether these lines are perpendicular. We have y equals 2x plus 1 and y equals negative 2x plus 6. So y equals 2x plus 1 and y equals negative 1/2 x plus 6. So the slopes are m sub 1 equals 2. The slope here is m sub 2 equals negative 1/2. So let's multiply them. So we have 2 times negative 1/2. This is also known as 2 over 1 times negative 1 over 2. 2 times negative 1, negative 2. 1 times 2 is 2. When you divide this, you end up with negative 1. And per our rule, the product of two slopes, when multiplied together, if their outcome is negative 1, the two slopes are perpendicular. Therefore, these two equations tell you that these two lines will be perpendicular. Let's look at another example. Example number 3. Write the equation of a line parallel to y equals negative 3x plus 4, passing through 2, 7. So the first thing we want to do is a parallel line must have the same slope. So we have m equals negative 3. And now we're going to use point slope form because we do have one point and that's all we need. So we have y, just going to label these, y minus 7 equals negative 3, parentheses x minus 2. And multiplying the 3 times the x and the 3 times the 2, our equation changes to negative 3x plus 6, because a negative 3 times a negative 2 will generate a positive 6. From there, we're going to add 7 to the left and the right of the equation. And that leaves us with y equals negative 3x plus 13. Therefore, y equals negative 3x plus 13 is the final answer. So write the equation of a line parallel to this line passing through 2, 7. This would be the result. Let's move on to another one. Example number 4. Write the equation of a line perpendicular to y equals 2x minus 5 passing through 4, 1. Write the equation of a line perpendicular to y equals 2x minus 5 passing through 4, 1. So the original slope is 2. So we have m equals 2. The negative reciprocal is negative 1/2. So the perpendicular slope is m equals negative 1/2. This is the symbol for the perpendicular. So perpendicular slope would be negative 1/2. So the perpendicular slope is m equals negative 1/2. Now we're going to use point slope form. So we have y minus 1 equals negative 1/2, parentheses x minus 4. Computing, we have negative 1, or y minus 1 equals negative 1/2 x plus 2. From there, we're going to add 1 to both sides. That leaves us with y equals negative 1/2 x plus 3. So the final answer for writing the equation of a line that's perpendicular to this, passing through this, is as follows. So notice the sequence. We know the slope for this one. So all we needed to know was the negative reciprocal. That's negative 1/2. And then, of course, you can multiply those two to see that the outcome would be negative 1. Once we get the negative slope or the perpendicular slope, then we can proceed with the point slope form. Now, I want you to pause and try this question here. Okay, write the equation of the line perpendicular to y equals negative 3/4 x plus 2 passing through 6, negative 1. So first of all, the original slope is negative 3/4. The negative reciprocal is 4/3. And we can use the point slope formula to find that out. So y or excuse me, to find out what the equation is. So y plus 1 equals 4/3 x minus 6. Computing. Okay. 4 times 6 is 24. 24 divided by 3 is 8. And we're going to subtract 1. Now over here, you want to be very careful because we have minus 8 or negative 8 minus 1. We have 4/3 x minus 9. So that would be our final equation. Now, here we have the reasoning question. The reasoning question is, consider these two lines. We have y equals 2x plus 3 and 2y equals negative x plus 8. Are the lines parallel, perpendicular, or neither? Because sometimes you can have parallel lines, you can have lines that are neither parallel nor perpendicular. Because remember, one of the contingencies of having a perpendicular line is that they must create a right triangle, or excuse me, a right angle. The first equation is already in point or slope-intercept form. Notice it's in y equals mx plus b. But this one is in what is called implicit form. This is explicit. This is implicit. So this tells us what the slope is already. The slope of m sub 1 is 2. We don't know what the slope is here, so we have to rewrite this equation. How do we rewrite it? We have 2y equals negative x plus 8. So the first thing you want to do is divide both sides by 2. When dividing both sides by 2, remember, even though there's no number present, negative x is also the same as negative 1x. So I'm going to write this as negative 1/2 x. And then 8 divided by 2 is going to give me a positive 4. So y equals negative 1/2 x plus 4. Now let's multiply the slopes together. So m sub 2 is negative 1/2. And remember, it's m sub 1 times m sub 2, and it must equal negative 1. So m sub 1 is 2, or 2 over 1, times m sub 2, which is negative 1/2. 2 times negative 1 is negative 2. 1 times 2 is 2. So this checks out. So this tells me that therefore these two lines are perpendicular. Notice the rigor here. Notice the rigor. Sometimes the slope is not immediately visible, right? Sometimes the slope is not immediately visible. You may have to rewrite the equation before comparing the lines. So just a final review, parallel lines are m sub 1 equals m sub 2. This is parallel. Perpendicular lines are m sub 1 times m sub 2, and they must equal negative 1. That is a perpendicular line. So perpendicular, parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. And when writing a new equation, you want to first determine the required slope, then use the point you are given. In the next video, we will complete our study of lines by combining slope, equations, parallel lines, perpendicular relationships, and applications into one final analysis. So I'll see you in the next one. Thank you for watching.